So we are now in the final section, section 5, the integer type section. Let's look at question 18 now. Question 18 says, a cylindrical tube of cross-sectional area A and length L is filled with an ideal gas. Temperature of the gas varies linearly from T0 at one end to 2 T0 at the other end. Assume pressure P is uniform throughout. The number of moles of gas is given by PAL by 4 RT0 ln X. Find the value of X. So to solve this, I just draw a cylindrical tube. Let's say this distance is R. We take an element of width dr. Area of cross section, of course, is A. So within this, the temperature on this side is T0 and temperature on this side is 2 T0 and this length is L. We can see that temperature varies linearly, so temperature T as a function of R can be written as T0 plus 2 T0 minus T0 by L, that means T0 by L into R. And we can check at R equal to 0 temperature is T0, at R equal to L temperature is 2 T0. So we apply ideal gas equation for this volume. The volume will be A dr, let's call it dV is equal to A dr. We have to find the number of moles. So we can see that pressure is P and volume is A dr. PV equal to nRT. Let's call the number of moles as dN. R, and temperature there is T0 into 1 plus R by L, which means dN can be written as PA dr PA dr by RT0 into 1 plus R upon L. If we integrate with proper limits, we'll get the number of moles in the tube, and this is equal to PA by RT0 ln 1 plus R by L, and the coefficient of R is 1 by L, so I divide by 1 by L, so that means L will go in the numerator. Value of R goes from 0 to L. So this is equal to then PAL by RT0 ln 2. Now if we compare it with PAL by 4 RT0 ln X, then value of X will clearly be 16. And why? Because 16 is equal to 2 to the power 4, and if I put X as 2 to the power 4, X will be 4 ln 2, and so it will match exactly. So answer to question 18 is 16. We can now go to the next question now. Question 19 says, in the circuit shown, a current I equal to 600 microampere enters through A and leaves through B. Reading of the identical voltmeters V1 and V2 are 20 volt and 30 volt respectively. Find the value of R in kilo ohm. Well, again it's a question from current electricity. The current I is 600 microampere. Potential difference across voltmeter V1 and V2 is 20 volt and 30 volt respectively. That means VA minus VB, we can see that is clearly equal to, in this particular case, 50 volt. Now if I look at these 2 points, potential difference between these 2 points is 20 volt, current is 600 microampere. If I assume that the voltmeter has resistance RV, then resistance between these 2 points, let's call them A and B, is equal to R into RV by R plus RV, and this means we have R into RV by R plus RV equals 20 by 600 into 10 to the power 6. Let's simplify this. Okay, so this is the value in SI units. Now if I apply the same concept here, we will have here between these 2 points, these R and R are in series and this is RV in parallel. So we will have 2R into RV divided by 2R plus RV is equal to 30 into 10 to the power 6 by 600 by the same concept. And let's call it equation 1, let's call it equation 2. Let's divide equation 2 by equation 1, and if we do that, what do we get? So 2 RV by RV will be 2, and then here you have 2R plus RV, and then the numerator will be R plus RV is equal to 3 by 2. We have divided equation 2 by equation 1, left hand side by left hand side and right hand side by right hand side. On cross multiplying we get 4R plus 4RV is equal to 6R plus 3RV, or RV equals 2R. So now it's pretty straightforward. The resistance between these 2 points R RV by R plus RV can be written as R into 2R by R plus 2R, that means 3R, or it is 2R by 3, and its value is, we put the value from equation 1, so this is 20 by 600 into 10 to the power 3 kilo ohm, because 10 to the power 6 ohm can be written as 10 to the power 3 kilo ohm, and this value is equal to 200 by 6, right? I take 10 from here, so 200 by 6 kilo ohm. And so R is equal to 200 by 6 into 3 by 2 kilo ohm, and that is equal to 50 kilo ohm. So answer to question 19 is 50. Let's go to the next question now. Well, now we have come to the final question of this test. Question number 20. Question 20 says 1 mole of an ideal gas is carried through a thermodynamic cycle as shown in the figure. The cyclic process consists of adiabatic, isothermal and isochoric processes. The value of Cp by Cv of the gas is given by P by Q, where P and Q are co-prime numbers. Find the value of P plus Q. It's given that use ln2 is equal to 0.7 and ln3 equals 1.1. So among the 3 processes which are there in this cyclic process, one is adiabatic, one is isochoric. Isochoric is obvious, AB is isochoric, and one is isothermal. Now if we look at between process BC and CA, if one is isothermal and the other is adiabatic, then clearly process CA is adiabatic and process BC will be isothermal. For the simple reason that the PV graph for adiabatic process will be steeper than the PV graph for an isothermal process. Okay. So based on this, let's go ahead. Well, so this is an isothermal process. Here you have volume at point B, volume is V0, pressure is P0, and since temperature at B and C are same, so Vc must be equal to V0 by 3, since pressure has become 3 times. And here it is again V0. So we apply the conditions of adiabatic process for process Ca, and which is PV gamma is equal to constant. Then we can get gamma, and once we get gamma, basically it's about gamma that we have to find. Cp by Cv is nothing but the gamma. So for process Ca we can write pressure at point C is 3P0, volume is V0 by 3, Pv to the power gamma is equal to P0 by 2 into V0 to the power gamma. On simplifying, we get 3 by 3 to the power gamma is equal to 1 by 2, or 6 is equal to 3 to the power gamma. Taking log on both sides, we get 6 is 2 into 3, so we get ln2 plus ln3 equals gamma ln3, and so gamma is equal to 0.7 plus 1.1 divided by 1.1, or it is equal to 18 by 11. So P is 18 and Q is 11, and so P plus Q is 29. So answer to question 20 is 29. Well students, with that we come to the close of this quick solutions. Hope you have found the solutions useful and helpful. I wish you all the very best for your preparations. Goodbye for now.